Okay, question 2. So it's a question which is looking at probability and counting outcomes, so fundamental principles of counting. Okay, so when Maeve's team play a match, they can win, draw, or lose. So there's 3 outcomes there. Fill in the table below to show the 9 possible outcomes when Maeve's team play 2 matches. 1 is already done. So you're looking at 2 matches, match 1 on the left, match 2 on the top here. Okay, so these are your 2 matches, and you've got a win, lose, or draw for the 3 options in both cases. So you're basically plotting 2 wins here, a win and a draw, which has been done for you, and a win and a loss. So which basically means the first game we won it, or Maeve's team won it, and the second game they lost. So that's the first line. The next one then is where the first game was drawn across the board. So you can put D, D, D in there. The second game was a win. The second game in this case was a draw, and the next one was a loss. Then the last one is where match 1 was lost in each case. Second game was a win. Second game was a draw, and second game was a loss. So that's all they're looking for there. Okay, so part B. Maeve thinks that each outcome is equally likely. So we're talking about probability here, if they're using this term. Based on this, find the probability that when Maeve's team play 2 matches, they win at least 1 match. So we're going back to the table then and looking for all the cases where we had at least 1 win. So we have 2 wins here, so that's definitely going to qualify. We have 1 here, we have 1 here, we have 1 here, and we have 1 here. So these are the 5 outcomes where we had at least 1 win. In one case we had 2 wins, but they're looking for at least 1. So outcomes where Maeve's team won at least 1 match is equal to 5. Okay, from above. The total number of outcomes we know is 9, so that's 3 by 3. So the probability then is equal to 5 all over 9. And they said to give your answer as a fraction, so you can leave it like this. So the answer is 5 over 9. Okay, Maeve's team play 5 matches in a competition, work out the total number of different possible outcomes for Maeve's team for these 5 matches. For example, one possible outcome would be win-win, lose, draw, win. So you could write out all of these, but there isn't really any need to do that. So each game has 3 outcomes. So if you have 5 games, means you've got 3 outcomes by 3 outcomes by 3 outcomes by 3 outcomes by 3 outcomes. So that's game number 1, that's game number 2, game number 3, game number 4, and game number 5. So in each case, you're going to have 3 different outcomes for each one. So the answer here then is going to be 3 to the power of 5, which if you do that on your calculator, you will get the answer of 243. So that's the total number of different possible outcomes for Maeve's team for each one, where you've got 5 games. Okay, so that's part C. Now, Maeve's team play 11 matches in a league. The table below shows the number of goals that Maeve's team score in each of the 11 matches. Okay, so game number 1, they scored 3 goals. Game number 2, they scored 1 goal, and so on. So work out the mean number of goals that Maeve's team score per match. So you basically want to add each of these up and divide by the number of games, and we've been told that the number of games is 11. In other words, to calculate the mean, it's the sum divided by the count of games here. So the sum of the goals divided by the count of the games. Okay, so 3 plus 1 plus 1 plus 0 plus 2 plus 7 plus 1 plus 0 plus 2 plus 1 plus 3 all over, and there should be 11 here because that's what they've told us. So that's 4, 8, and 3, 11, yeah. So the answer then is 1.9 goals per match. Okay, that's that one. Next one then is complete the pie chart below to summarize the data above, showing the proportion of their games in which Maeve's team scored 0 goals, 1 goal, and so on. Right, so they haven't done it up here, but essentially if you take each of these numbers, so how many different numbers have we got here? We've got a 0, we've got a 1, 2, so I've got 4 of those. For zeros, I've got 2. So I'm basically building a frequency for each of the outcomes. For 2, I've got a 1 here, I've got another one here. Next one is 3, so I've got 2 games where we had 3, and then the last one is 7, sort of an outlier. Okay, so with that then I can work out that where we had 0 goals, if I write goals here, and frequency, if you like, is 2. For 1 goal, I've got 4. For 2 goals, I've got 1, 2. For 3 goals, I've got 1, 2. And for 7 goals, I've got the outlier, which is 1. Okay, these should add up. If I've collected them all, these should add up to 11. So 6, 10, 11. Yeah, that's fine. Okay. So then what you need to do is take each of the frequencies and divide them by 11. So this one basically means I've got 2 out of 11. Let's take the 7 first. So 7 is 1 out of 11. So I'm going to have to get an 11th of this here in terms of the pie chart. So that's the first one. The next one, which there's 3 of them, 3, 2, and 0. 3, 2, and 0, they all have 2 11ths. And the last one then is the 7. Sorry, 1 first. Forgot about the 1. So the 1 is the largest pie. So that's 4 over 11. And the 7 then is 1, which I've already covered. Okay. So 1/11 then multiplied by 360 degrees is going to give us some number. 2 11ths is going to give us another. And 4 11ths is going to give us another. So that's how we're going to get the angles for these. So the first one then is, when I do this on the calculator, 32.72 degrees. The second one, I just put it here. Uh, 2 over 11 is 65.45 degrees. And the last one, 4 out of 11 multiplied by 360 is 130.9 recurring degrees. Okay, so let's take the number one, the most frequent one first. So again, I'm going to do this roughly, but you'll be doing this with your protractor. So let's assume that's a perfectly straight line. So the first one, so that's 90. So the first one is 130. So I'm going to say that's one goal. It's a bit small. So that is my 7 goals. Then if I split this in 3, so this is 3 goals. This is 2 goals. This is 0 goals. Okay, so that gives me the figures for completing the pie chart. That's the end of question 2.